Okay, so you can see graphing, this question is about graphing exponentials. Key bits of information, you can see the first part is graphing that function. We've got a graph there. We've had to work out by substituting in the x value to get the y value. The points have been plotted and the graph has been drawn, joining up all those bits. So the student sent through this question not because they had a problem with the first part, but because they had a problem with the second part. To be able to complete the the second part, you need to have an answer for the first, because it states about drawing a straight line and also solving the equation. So the first thing we should notice is that this equation is similar but different from the original one that we looked at. So if I write these out, we can have a look at those differences. So we're looking at b here. So the original function that we've graphed is y is equal to 2 times 0.5 to the power of x minus 1. And the domain is between -1 and 2, but that's also the same for the second one, so we can ignore that. Then we look at the equation that we need to solve, which is 2 times 0.5x plus 2x minus 3.5 is equal to 0. So it has some similarities. I might just change the color here. So you can see that the 2 is the same. The exponential is the same, so we're not going to touch that. But then in the original function, we don't have any x. So for us to be able to use the graph in the part A, we need to be able to change this equation so that the left-hand side is the same. Then making an equation on the right-hand side, and then it would be the intersection of those two lines would be our answer. So for me to change the second function to be similar to the first function, first thing I'm going to have to do is I'm going to have to remove the 2x. All right, so we've still got 2 times 0.5x. They cancel out. And also, because we've got the -1 there, we've got minus 3.5, so I have to add 2. 2.5. Okay, so what that means for our final equation is on the left-hand side, we end up with -1. So the left-hand side is the same as our original function. Now, to balance that out, we have to do the same on the right-hand side. So it's going to be 0 minus 2x plus 2.5. Sorry, I'll move that over. Meaning that our equation's been rearranged to end up with minus 2x plus 2.5 on the right-hand side. So, because we have already graphed this left-hand side, if I graph the right-hand side with the equation y is equal to minus 2x plus 2.5, wherever those two lines, those two lines intersect will be what our answer is. So if I'm graphing this line, key things I can get from the equation, remember it's y is equal to mx plus c. So the gradient is minus 2 and the y-intercept is plus 2.5. So going to my graph, first thing I need to do is I need to find my y-intercept at 2.5, and then I need to create the gradient. So if we do our gradient, it's -2, so that's a run of 1. Oh, sorry, that's a run of 1. And then it goes down 2, so it would go down all the way to 0.5. So my second point would be there. So across 1, down 2. I'll get rid of that so that it doesn't look too messy. Okay, then we get our ruler. Again, as we've done before, try to match up those 2 points the best we can with our drawing so that it goes through exactly through those 2 points. It's hard to do on a screen. All right, rule our line. Okay, and it's probably a good idea to label our lines as well. So this is y is equal to -2x plus 2.5, and we probably should have labeled the original function as well, which I can do quickly now, which is y is equal to 2 times 0.5x minus 1. You can see the point of intersection is there. And then what we can do is try to then work out what the x value of that is. So if we read up, it means x would be 7. So I'm saying that's x equal to 1.35. So putting in our answer is x is equal to 1.35. So moving on to the third part of the question, it then talks about the original function again, which we've already drawn up the top there. So there are no solutions for the equation where k is an integer. Complete the following statements. What is the highest value of k? And to answer this question, I suppose the key point is that we need to think about exponential equations. So the general form of exponential equations look like this. Okay, with different parts. So the b is called the base. Okay, and in this case, the base would be the 0.5. You might also have a constant out front. Here, sometimes it has a number of different names. It could be the power, the index, the exponential, or the exponent, sorry. But I suppose for this question, the key point is this value on the outside, which would be the asymptote. So in other like straight lines, parabolas, and things like that, the constant or the value that's by itself with no x attached to it is described as the y-intercept. So we need to understand with exponentials, there's a point where it doesn't, that the function will never touch. It's a limit. And actually, I'll show you that on a GeoGebra. Okay, so this is a GeoGebra applet that shows us the effect of the exponential formula. So you can see it there. So what we're looking for in this question is the effect if you change, what happens if you change A. You can see it makes it steeper or not. Okay. Trying to get it. Yep. And so that would be 2x. You can see by changing C, which is the green one, again, it changed the y-intercept and the steepness. So again, we can, and if it's negative, it's reflected in the y-axis. Then if we change, oh, and actually I can't have that 0, otherwise it's a flat line. So I'll keep it as 1. Okay. And then obviously if K changes, that can have an effect as well. Again, changing the steepness, and then if that becomes negative, it goes the other way. Again, I'll make that back to 1. But the key thing to this question is talking about the asymptote. So if I change this constant and we have a number by itself on the outside, you can see that it moves up and down. It's the whole thing is translated, whatever that number is. So you can see with an exponential, as we get closer and closer to our closer and closer to this point, you can see that it's it ends up being very, very close, but it will never touch. So that's actually the highest number that we can have no solution. So what I'll do is I'll adjust this so it fits our question. So you can now see that I've changed the function so it's the same as the question, and you can see that the asymptote is -1. So as our graph increases, you can see that it gets smaller and smaller and smaller, and then below that we don't have a solution. So in other words, the highest value that we can have a solution is -1. So going back to our question, what is the highest value that K can be? It can be -1. And simply, we can read that straight off the question by reading that value there. Again, the equation of the asymptote of the graph y is, it's going to be y is equal to -1. So it is well worth spending some time exploring exponentials if you, and what time you have remaining.